Second project is related to replicating financial advice, and that was more of a sort of a contract kind of thing, trying to build an app to do a certain thing for one of our partners. And then the third project that I'm going to talk about is a work in progress. We're getting very close to the end of that, and just related to sort of outcomes and what drives good outcomes. Is it how you save? Is it how you invest? What does the data tell us? So the Financial Wellness Lab is hosted at the University of Western Ontario. We have academic partners at Ivy, Wilfrid, Laurier, UBC Okanagan, University of Winnipeg and York. A lot of students have been involved, a lot of NSERC USRA. We employ a couple of full-time data engineers. I won't necessarily read our mandate, but essentially what we do is we try and use ideas from, actuarial science, quantitative finance, and data science to really think about financial wellness, help individual Canadians become more financially resilient. And that involves, there's sort of two streams, I guess, that we are working on. One is related to financial resilience of individuals. How do you spend? How do you save? Measuring financial resilience, I guess. And then on the other side, we have a lot of data that we've gotten from registered investment dealers, wealth management professionals, and that's what I'm going to talk about today. So not so much the financial resilience, but more the sort of how do people invest. These are a few of our partners. We're currently funded, and every partner contributes either a little bit of money or a lot of data, or sometimes both. And we're currently funded primarily by an NSERC Alliance grant, funding for 3 years. And this all started out of the Field CCAM program, and that initial collaboration went really well, and led to this Financial Wellness Lab. Okay, so let's get started talking about the actual projects. So elicited risk, what would elicited risk be? That would be, well, maybe elicited risk would be if I actually ask you what your risk tolerance is and you tell me, okay? And then revealed risk is different. Revealed risk would be, you said that you're very aggressive and you're not afraid to gamble, but I've actually watched you operate and you're a lot more risk averse than either you think you are or you say that you are. And so we're interested in sort of the comparison between those two things. How do people say they feel about risk? And then when it comes down to it, how do they actually act? And are those two things consistent? That's big picture kind of what we're talking about when we say elicited and revealed risk. So this all started with what we thought was a really simple problem that was posed to us by one of our partners. And so the two inputs here are what I would call a prescribed portfolio and an actual portfolio. And I'll explain what I mean by prescribed and actual in a moment. For now, I'll make sure we understand what these numbers mean. So any asset, any investment asset that's sold in Canada has to have a risk rating associated with it. There's 5 buckets. There's low risk, there's low medium, there's medium risk, there's medium high, and then there's high risk. So if I'm gonna put an asset, if I'm gonna put an investment into my portfolio through an investment dealer, it has to have one of these 5 labels attached to it. And so what these numbers represent, 25% of your portfolio is invested in low risk assets. What those low risk assets are is not described by these 5 numbers. This just means that 25% of your portfolio is in low risk, whatever those low risk assets are. Okay, so this portfolio here would be 25% low risk, 40% low medium, 35% medium, and then nothing in the high risk or the medium high risk. Okay, so that's how we interpret the numbers. The prescribed portfolio, so when you start meeting with an advisor, you sit down, you have a conversation, or maybe a couple of conversations. The advisor gets a sense of who you are. You would fill out a survey, you'd fill out a questionnaire, maybe 20 questions, some demographic stuff, some risk tolerance stuff. And then as a result of these interactions, of these conversations, the advisor would come up with a recommendation. So based on our conversations, I think you should be in this portfolio right here. 25, 40, 30. This would be a really conservative portfolio. And so that's what the prescription is. And so we have access to that. When the client meets with the advisor has to, by law, come up with one of these prescriptions. And so that's what the prescribed portfolio is. And this should, because it's based on a conversation between an expert and the individual, this is that elicited risk. So we sort of think about this as how the person says they feel about risk. But there's no guarantee that when they go and construct their portfolio, that it corresponds to this. And so this was a recommendation that was made on the basis of a couple of conversations. And this is what the client actually did. And so there's a pretty big deviation here. Well, arguable. But this was the prescription. This is what the advisor recommended based on their expert knowledge, based on the interactions they've had with the client. And then this is how the client is actually invested. So 5% low risk, 15% low medium, so on and so forth. Okay, so there's a difference here, right? And what our partner was really interested in was quantifying that difference for a variety of reasons. It could facilitate a conversation if an advisor doesn't think that the client is taking on enough risk to get where they say they want to go in retirement. They would want to sort of point to this discrepancy. If the client wants to make a trade, if they want to rebalance the portfolio, but the advisor feels that's going to move them further away from the prescription, it would be nice to have a way to sort of quantify that, right? So that's kind of what we're interested in. And so the output that we're looking for here is just a single number that tells us how far away we are from our prescribed allocation. Is this new trade going to put me closer to or further away from the prescribed allocation? That's what we're trying to do. And we looked at this, and initially we thought this is really simple. We'll like have an answer in a week and we'll be done and we'll be good to go. Seems like a really simple measurement problem, right? Either I look at this as two 5-dimensional vectors and I know how to do distances in various ways between vectors, or you notice these are, these are probability distributions. And so we know how to measure distances between probability distributions, right? Kolbach-Leibler divergence or something like that. So on the face of it, seemed really, really simple, really, really straightforward. And it is pretty straightforward. Sheepishly, I don't think we realized, I think we overestimated how simple it was at the beginning. Okay. Does anybody see the issue? Let's just say I'm going to look at these as 5-dimensional vectors and I'm going to use Euclidean distance. Anybody see the problem with that? And it took us, again, I don't want to say I'm embarrassed, but it sheepishly admit that it took us a little bit longer than probably it should have to realize what the issue is here. Yeah.
Well, my idea is that if you, for instance, if the difference, if one of them, for instance, is they differ. The two vectors could differ by the same amount, but one because it has a lot. So say they all start with say that your baseline is 20% in all of them, but then one of them has it's some distance away because it has a lot more in the lowest risk category, and another one could be the same distance away because it has a lot more in the highest risk category. That's
it's the ordering. Yeah, exactly. Is that where you're going to say basically the same thing?
So yeah, basically, I mean, it makes a difference if the first one is prescribed and the other one the actual portfolio, or the other way around. So,
yeah, absolutely not symmetric, right? Yeah. Right. And so it took us a little bit of while to realize this, but and if not everybody else is following along, imagine the prescribed portfolio is 0, 0, 0, 0, and 100, most aggressive recommendation that you could have. If my actual portfolio, think about an actual portfolio that's 100% low risk, 0 everywhere else, another portfolio that's 100% medium risk, 0 everywhere else. If we just use the Euclidean distance, those two portfolios are equidistant from the super aggressive prescription, right? And so that's the problem. It didn't occur to us right away until we started looking at the data and saying, okay, we're going to do our calculations this way. Now let's go look at a few trades and see if they actually, a few trades that clearly move the client towards or away from their goal. Let's make sure the metric is telling us that happened, and we were getting the exact opposite sometimes. So again, that's the problem, right? There's an ordering issue here. If we just look component-wise and then average anything that's just a component-wise comparison, it's going to fall apart and it's not going to do what we want. Same thing if we use Cole-Black-Leibler divergence, and there's another issue there, the way zeros are treated. If the advisor didn't actually place a recommendation on a particular category, that could really lead to some unanticipated or unintended, unwanted consequences in the calculation. Okay, so what seems like a really simple problem is a little bit more complicated. So how did we deal with this? So what we did is we said, I'm going to choose one representative asset from each of the 5 risk buckets. So your low risk would be like a money market ETF, and your high risk would be like a gold ETF or something like that. And then I think the medium risk would have been like 60 biggest companies in the TSX. So we choose one representative asset from each risk bucket. Once we've chosen those, we go get historical data, means, volatilities, correlations. And then what we're going to do is we're going to assume that, sorry, that shouldn't say very, that should say every dollar that's invested in a particular risk bucket, we're just going to assume is fully invested in that representative asset. That's not entirely in agreement with reality. If you look into the data that we're working with, and I'll describe the data actually in a moment, but if you look into the data that we're working with, you know, an investor in their medium risk holdings could be holding 3 different assets in there. And the number of assets that are available in our data set, how many was it, like 3,000 Yang? Was it, how many distinct securities did we see in there? Over 30,000. We just don't have enough data to estimate that many parameters. So a simplifying assumption, the one that was basically, but that was necessary. So we assume every dollar invested in the bucket is fully invested in that representative asset. We have all the parameters we need to compute risk measures for portfolios. And then so what we do is we just calculate the value at risk for each portfolio. We calculate the value at risk for the prescribed. We calculate the value at risk for the actual, and then we just look at the difference. And part of the reason I'm going slowly through this is, you know, we're in quantitative finance. We understand that value at risk as a tool for managing risk in large financial institutions has some very well-known shortcomings. When we started talking about value at risk and interpreting it, sort of, you know, what does your worst day out of 100 look like? What does your worst year out of 10 look like? Our partners found that a really useful way of facilitating the conversation about risk with their clients. So although value at risk is well known to have some pretty big holes and some pretty big shortcomings, when it comes to just like helping the conversation, helping people that aren't necessarily interested in thinking or able to think about things really sort of mathematically, our partners found that this was a really useful way of facilitating that conversation and helping sort of put things into context for their clients, which I found very enlightening, and I thought I would pass it on to you as well. Okay, so this, yes, absolutely.
We use a full blown value at risk model, like for all the securities and banks will do that.
Yeah, I mean, I think the biggest limitation with us is we got 30,000 securities. Like, there's just no way we're going to be able to estimate the parameters for all of those things.
Banks do that on a daily basis. You track the models for it.
I mean, I don't think we just, banks, we don't have access to the same, yeah.
So it's more,
Yeah,
but the idea is really kind of simplified model.
absolutely. Simplified model that can help, you know, and really what we're interested in is like, are you taking on too much risk or not enough risk? The exact number, like, is it 14 basis points more or 140? Like, we're just more interested in the sign of the gap, I guess, if that makes sense. Okay, so what did we sort of test this on? We have transaction level account detail for over 50,000 different investment accounts. We now have data over a longer period, but when we were doing this, we had about 5 months in 2019. So this would cover 311 different advisors, over 27,000 different clients, and all different types of accounts. So there's there's non-registered accounts, there's RIFs, there's RESPs, there are RSPs. So a very wide variety of different types of accounts. And what we do is we calculate the difference between the actual VAR and the prescribed VAR. We do that for every account. We do it every day, and then we just sort of average through time. And so what does it mean? We're calculating this discrepancy. So we're going to take actual VAR and we're going to subtract off prescribed VAR. So before we start looking at the results, what does it mean if that's negative? I take actual VAR, the VAR on the actual portfolio the person's actually holding. I take the VAR on the prescription, what the advisor recommended. And then, so what does it mean if it's negative? What's the client doing? Which direction are they? Probably a simpler question than, but, well, this is the actual VAR. And then if I subtract off what the advisor said, so if this is negative, I'm not taking enough risk, right? So if this is negative, the advisor said I should be here and I take a few steps back and then that's my portfolio. If this discrepancy is positive, it means I'm taking on more risk than the advisor said I should, right? Okay, so negative means I'm under risked in a certain sense, if you will, and positive means I'm over risked in a certain sense, if you will. Yes. We did, I think it was monthly. It certainly wasn't daily. It was on a longer time scale than daily. I mean, I have it on my laptop, but I think it was probably monthly.
Yeah, but I think it's the wrong measure. Who cares about war? People don't want to lose money, so they don't want to lose more than 20% of the portfolio or something like that. So they care rather about drawdown or maximum loss, but not about war. People even don't understand what the war is.
Well, my response to that would be our partners cared about VAR. We talked a little bit about it. They liked it and they said, do that. That's the one we want. So we proposed a bunch of different ways of measuring risk and communicating. And they said, we like this one.
Okay.
For what I mean, I'm not saying that they're right or they're wrong, but the partners said we like it. And so that's why we pursued it. No, but it's okay. So this is the thing. This is a really good question. Not everybody's retired, right? So a lot of the people in here are maybe still 20 years away from retirement. They're getting close. They're not just starting out. It's sort of an older sample. We looked at a younger sample as well. But this whole idea of, okay, VAR represents kind of what the worst year out of 20 might look like, gives you kind of a lower bound maybe on what that worst year out of 20 might look like, really seems to resonate with people who don't necessarily have a mathematical background, right? Being able to say something like, okay, you're going to get a 7% return here and the volatility is 15% doesn't necessarily resonate with most people. It resonates with us. But being able to say something like your worst year out of 20, it's going to be a 20% loss. We need to be prepared for this, right? That's how it's being used, if that makes sense. Absolutely, that's exactly the problem. Absolutely, but value at risk puts it into units that like I said, like just happen to resonate with people. I don't know why, but that's been our partner's experience. Okay. I mean, we could talk about, there's all sorts of different things we could do. Like we could do a CVAR. Are you thinking of like, okay.
CVAR is equally wrong. Sorry, I'm very.
It's fine. This is,
I'm not criticizing at all. I mean, I just.
I value any and all feedback. So I'm
I mean,
interested in hearing your
I
thoughts.
would rather put it in the language like what it would be maximum tolerance level in percentage of your portfolio.
Oh.
You would agree to lose like 50%. Are you agree to that, or 20%? Are you agree to that? Because you're speaking about loss per month, but people are not on monthly basis.
Right.
On retirement or whatever. They are like in different frame.
Right. So we could convert it into years. Yeah, I think we
Yeah,
did.
but anyway, sorry for
Yeah, no, that's good. And actually, a point that you made, when communicating it to clients, leaving it in percentage terms isn't really all that meaning, like it wasn't all that useful. Every advisor we spoke to said, you have to convert this back into dollars, or else people just aren't going to pay attention. Okay, so this is what we did. Negative means you're under risk, you're not taking on as much as the advisor said you should be, and positive means you're taking on too much relative to what the advisor said. And so just sort of to make sure that it seemed like this is doing what we were hoping it would. We found that the prescribed VAR, so that's in essence the risk level that the advisor is recommending, positively correlated with income and investment knowledge. So they're people who earn less and claim that they know less are getting prescribed less risky portfolios. People who earn more or say that they are more knowledgeable are being prescribed riskier portfolios. And that's as it should be. You would argue. Negatively correlated with age, and this is a really important one. Individuals in there that are 65 are getting much lower risk recommendations than individuals that are 40, as it should be. Conventional wisdom would say margin accounts have the highest prescribed VAR, right? And RIF accounts have the lowest. So, and we looked at a whole bunch of different demographic things. We really tried to make sure it was doing what we're saying or what we were expecting it to do. And one of the things that came out of this is we came to the overwhelming conclusion that the individuals here are getting good advice, that the advisors are giving sensible advice, and that's reassuring. Okay, and so now what we're going to do is I'm going to look at all the accounts. And so there's multiple accounts per client, there's different types of accounts, there's RSPs, there's margin accounts, all sorts of different accounts. No matter how we break this down, if we look at it with just the RSPs, we get something similar. If we look at this with just the RIFs, we get something similar. If we look at this with just the margin accounts, we get something similar. If we look males, females, something similar. Old, young, right? Like this is a really, really persistent pattern. And so that's why I'm showing it to you here with all accounts. And what you'll notice is this is just a histogram of all of the different accounts that we have versus the discrepancy in VAR, basis points. I don't want to worry too much about the numbers. I just want to worry about the sign. And I want to look at how many of these are negative. I can't remember the actual percentage, but it's fairly clear that the vast majority of the accounts are under risked, right? The vast majority of the accounts are taking on, or the vast majority of the portfolios are taking on less risk than the advisor prescribed. And so this was one of the overwhelming conclusions we came to when we were looking through the data, is that the actual VAR is systematically transcends any sort of demographic characteristic, account type that you can imagine, consistently and systematically lower than prescribed VAR. We're really confused about this at first. Any question before I move on to the next slide and kind of what we thought at first?
And that also transcended age group.
Transcends age group. Now, it's a very, it's not a, in terms of age, it's not a diverse population. So these are people that, and these are people who are working with wealth managers, right? So they're older, most of them are between 45 and 65, say, they have a lot of money to invest. So this is not representative of the Canadian population by any stretch. But given that we're in this population, yeah. Yes. Yeah, but no matter how we looked at this, it was the same thing. Like it was almost universal, which was really surprising to us. So being cynical, our first thought was, okay, so being cynical, the first thought was, this is just advisors, not wanting to get sued. So I'm actually probably going to put you in a portfolio here. If it doesn't do that well, I don't want you to sue me. So I'm going to give you a recommendation up here. We're going to put you a portfolio in here. And then if things go wrong, I'm going to say, look, we were actually more conservative than I thought we should be. You can't sue me. We were very cynical about it. A lot of people we talked to sort of felt the same thing. We thought this was kind of a this was more like kind of a legal liability thing on the part of advisors. That was our original thought, that this persistent discrepancy was advisors reasonably and understandably protecting themselves and not wanting to get sued. Recently, and I say here, we think we see this, we actually do see this now. The data that I described, the data that I just showed you, was older individuals that are working with advisors. So in order to get in the door and make it worthwhile to talk to an advisor, you need to have a certain amount of capital. So it's sort of a very limited slice of the population that actually can talk to human advisors. Then we got robo-advisor data, much newer accounts that hadn't been in existence for as long, much younger individuals, and they're talking to a robot instead of a human, and we see the same thing. So I said here, we still need to control for a few potentially confounding variables. We did that, and we're certain that we see it in the robo-advisor data as well. So it can't just be the human advisors who are trying to protect themselves, right? Because there's no human advisor here in the robo-advisor data we looked at. It's demographically a more diverse sample, and they're filling out a questionnaire, getting a recommendation, and then going. There's no human being there who's trying to avoid getting sued. And so the conclusion is maybe this is just human nature, right? I tell you, you should be taking, here's where you want to go in retirement. Here's how long you're going to be saving. Here's how much you're going to be saving. I kind of tell you, you need to be taking this much risk in order to get where you say you want to go in retirement. It looks like human is just taking a few steps back. So my advisor said I should be there. I'm going to take 4 steps back from the recommendation because I want to be cautious, and then I'm going to proceed. So that's kind of what this looks like. It would be really interesting to put this to sort of a more formal test, maybe get some behavioral finance viewpoints on this. And so the question becomes with the advisors, how do you encourage individuals to take a more appropriate level of risk based on all these inputs? Or maybe the other side of the coin is, look, you told me you wanted to golf 4 times a week. You wanted to take 1 vacation per year. You didn't want to cook a whole lot, so you wanted to eat in nice restaurants 3 months a week. To get there, you said you were going to save 10% of your salary. You don't want to take on a ton of risk, so you're going to be 50-50 bonds and equities. If you can't encourage, that's not going to get you where you need to go. So if you can't encourage them to say go 80-20 instead of 50-50 because they don't want to take that additional risk, maybe the conversation becomes how to set more realistic retirement goals. So if you don't want to take on this much risk, it's not golfing 4 times a week, it's golfing twice a week, sort of thing. So that was sort of the big takeaway. Again, really started as kind of a simple problem. Can you measure the difference between where the advisor said the person should be and where they actually are? The difference between elicited risk and revealed risk. And this was like what we thought really valuable insight, a really valuable byproduct of that project. So I don't have a whole lot more that I want to say about this. Did anybody have any questions before we move on? Yes. Sure. Yeah.
So when we're talking about robo-advisor, those are machine learning trained models. I mean, like, we don't know what are the input biases that have gone into training those robo models, right?
It's a great question.
So it would be the same as what you have in your data set as well, or very similar to that, unless they have meticulously weeded out the biases, worked for the biases. So it is possible that that's why we see that it's not just human nature, but that's what the data we have for it.
So that's a really interesting question. With this, maybe I shouldn't be calling this a robo-advisor. You go in and you answer whatever, 5-6 questions. We know what the questions are, and we also know the formula that's being used. It's not a black box. There's an actual formula that says that we have the mapping from responses to recommendation. Now, maybe, and we have the documentation that explains the motivation for all of this, because if you're going to get past regulators, you need to be able to explain everything. And so there was no model that was trained. It was a couple of experts that sat down and said, these are the questions that we're going to ask. Here's how we're going to map them. and here's a justification for that mapping. They may have built something in there, but I think we're sort of protected from that. Anyway, really good question.
Advices, but not face to face, but through another interface.
That's correct. Yeah. Does that make sense? Yeah. Okay. Awesome. Okay. So question 2 or project 2 is on replicating financial advice. And so again, this was we're going to build it where we are building, and we're essentially done building an app for our partner to use in the group RSP space to give advice to people that they're getting enrolled in group RSPs. And so let's set the stage. So we're going to build an app to give individual, very, very basic, like you should be 80-20 or you should be 50-50, right? Really basic sort of advice. Who are we giving this advice to? It's an individual that's beginning to save for retirement via group RSP, probably somebody who's young. Very likely this is their first job. And on day one, you know, the HR person comes in and says, fill out these forms about, you know, how much you want to save, how much you want to match, how do you want to invest. This individual is likely young, little to no savings, little to no investment knowledge, and very likely intimidated by the whole process, right? So we're not dealing with the 45-year-old who's making $250,000 a year and has been investing for years. We're dealing with somebody who is new to the market and is probably a little bit intimidated. That's who we're trying to serve with this app. And so the question was, again, in order to be worth an advisor's time, advisors need to pay the bills as well, right? And so in order to be worth an advisor's time, you have to have a certain amount of wealth accumulated. And otherwise, it's just not, it's not a sustainable business model for them. Okay, and so the question we want to ask is our target population here is very, very different from the types of people that can actually qualify for professional advice. And so what we want to do is answer a really simple question. If this individual right here had access to an advisor, what would that advisor have recommended? That's the question we're trying to answer. Can we replicate professional advice for those that would not otherwise have access? And I want to make sure I'm using the word replicate here and not replace, and I'm using that very specifically. The expert advice that the advisor gives to people who qualify is like an essential ingredient to this. We're not trying to replace that. We're just trying to say this segment of the population has access to that advice. We know they're experts, and we saw in the first project, like the people are getting good advice. The more and more we work with this data, the more convinced we are these advisors really do know what they're doing. Can we just sort of say, can we take that advice and replicate it for a much larger segment of the population? That's really what we're trying to do here. And so what is the data? We're going to train a model. And so we have nearly 5,000 RSP account applications. We're only paying attention to RSPs here because it's for a group RSP platform. They were completed with one of our partners, not one advisor, one of our partners, all of their advisors. So it's not just one of our partners and one advisor, it's one partner and then all of their advisors, probably hundreds of advisors. Every account that was opened between mid 2019 and early 2021. If you've worked with an advisor, when you work with an advisor, you fill out, this is a risk profile questionnaire, ask you some questions about how much money you have, how much investment knowledge you have, how much you have invested elsewhere, a few questions about risk tolerance. So you would, we have access to the individual's responses to that questionnaire. There's also a conversation that happens, or multiple conversation that happens. We don't have sort of the meeting notes. We don't have access to those. All we have access to are the answers to the questionnaire. So there is a little piece that we're missing. This is what we have access to, the responses. I think there's about, in this questionnaire, there's about 20. And then we have access to the recommendation that was ultimately made by the advisor. And the recommendation is one of 5 risk levels. Income growth, aggressive growth, balanced growth. And each one of those risk levels would be sort of a different portfolio. So the recommendation is relatively coarse, one of 5 risk levels. On the risk spectrum, risk level 1 would be a low risk portfolio, mostly bonds, money market. Risk level 5 would be a more high risk portfolio, probably almost 100% equities. And that's what the recommendation is. And so what we want to do is we want to build an algorithm that mimics the professional advisor's thought process, right? Again, trying to answer this question, can I build a model that takes the responses to these 20 questions, feed it in, and it's going to be very much a black box, feed these responses in, so we get an accurate recommendation out. That's what we're trying to build a model that does. Take the 20 responses to the questionnaire and then give a recommendation that is one of 5 portfolios at various locations on the risk spectrum. And so our first attempt, I don't know why we tried this first. We just did a simple nearest neighbors thing using only demographic information. I can't remember why we just started with demographics. How old are you? How much money do you make? Where do you live? Male, that kind of thing. And this was an epic fail. And I'm not sure why I'm not sure why I'm asking this question here. My motivation for putting this in is not clear to me at this time because I kind of have the answer here. But anybody want to guess why this didn't work? So if all I do is I want to make a prediction on what an advisor would have recommended to you. And so in order to make that prediction, I'm going to grab 100 people that are very similar to you demographically, and then I'm going to make a recommendation based on that. Turns out that works terribly. Everybody just gets the average recommendation across the entire population. So if the overall recommendation was a 3, if I do this nearest neighbor, identify the people who are similar to me demographically, everybody gets the same recommendation. Any idea why that is? Spoiler alert, it's kind of on the slide. Like what? If I only pay attention to demographic information, I don't get anywhere near what an advisor actually does in terms of recommendations. Any idea why that doesn't work?
I think it's overfitting to the. No, that's fine. I would think it's overfitting because we don't have the risk profile or the other information which would actually give the differences between the different clients for the model to learn from differences.
Absolutely. We're only looking at the demographic thing. We're not paying attention to the important qualities that an advisor actually pays attention to. It's not sort of who you are demographically, it's who you are personality wise. That's what advisors are paying attention to. And so if we just do a simple nearest neighbors with only demographic features, we might as well just we're not actually giving any customized advice. We're just giving everybody the average recommendation. Okay, and so what we did is on round 2, let's get a little bit more sophisticated. We're going to use more sophisticated predictive models. And what we're going to do is instead of just looking at the demographic stuff that was in the RPQ, we're going to look at everything that was in the RPQ and see if we can do a little bit better. That was much more successful. I'll have a slide. I'll show you some numbers very shortly. But what this tells us is that advisors, in fact, they're not really paying attention to demographics at all. They're paying attention to much more than demographics when they make these recommendations, right? And that's probably comforting. They're not just looking at me. What do I look like? How old do I look like? Do I look like I have a lot of money or not? Like they're actually getting to know me before they make that recommendation. I think that's good. Okay, so we tried, I mean, I don't want to get too much into this. This was certainly not, I am not a machine learning guy. This was not my role on the project. But I do just want to give you an idea of the different types of models that we tried, the different sort of criteria that we used to see how accurately we were making predictions. And we can do a really good job. So these are the results of K-fold validation of the various models with the various criteria. I think we used 10 folds, covered the whole sample. We could do quite a good job, 90% accuracy on predicting what an advisor would have told you if you had the wealth to walk through the door. And this is really, really encouraging. The nice thing about a lot of these models is they will give you a list of important predictors, right? There were 20 questions. And so we put all those 20 questions into the models, and the models can give us a ranked list, a rank ordered list of which of those questions are most important, carry the heaviest weight in the decision. Interestingly, income is only the 10th most important feature. Really, instead of asking 20 questions, well, the advisors are asking 20 questions on that questionnaire. Some questions they have to ask by law, but they're not actually necessarily paying attention to the responses when they make their or overly paying attention to those responses. You could probably get away with about just asking 5 or 6 questions, ignore the other 14 or 15, and that's what advisors are paying attention to. So, yes.
What are you predicting here? Here is a binary classification, so yes or no, male, female. So what kind of prediction are you
The
speaking about?
prediction is categorical 5 categories. So low risk. Are you in the lowest risk? Should you be in the lowest risk portfolio, the highest risk portfolio, and there's a spectrum of 5 there.
Oh, okay.
Does that, so there's 5 categories.
Okay.
And we're trying to predict that category.
Okay,
Does that make sense?
Yes.
And so, yeah, we could do a really good job. And that's really, really encouraging because that, you know, gives the potential for replicating advice to people who need it and wouldn't necessarily otherwise qualify for it. Yes.
So a lot of,
Thank you. So a lot of these top models, like their interpretability isn't the greatest, right? So does that come into play? Because usually when you go to a wealth manager and they give you some kind of like risk assessment, you can ask them, well, why did you put me in that bucket and not that?
Yeah.
And like with the risk questionnaire, you could do something like a factor analysis at least and like figure out what's important, what's leading to what. Whereas with a lot of these, if like you're doing a neural network past the couple, like you're 2 layers in and you just lose
Yeah,
interpretability.
and that's a really good question in this. For the group RSP space, there's less of a there's less of a regulatory hurdle for certain applications. There's not enough interpretability for it here to be able to explain it to regulators. Yeah, so that's absolutely. I mean, what we can do is we can look at the list of predictors and we can say, oh, wow, well, you know, the question where we asked them what they would do in a market downturn, that one was at the top of the list. So that's what advisors are paying the most attention to. Beyond that, we're not there yet. Yeah, that's a really good question. Yes.
The question is how you measure the importance of a feature.
Yeah, so I think, again, this is not my area of expertise, but there are certain like with a decision tree, right? There's criteria that you can use, information gain. So here's how well we can make our predictions with and without. Very, very standard, like built in.
I think you use the learning method. Based on the learning method, they will come out with a score, which gives
That's exactly
you
right.
the
That's exactly
importance
right.
of the feature. I see.
Yeah, and the numerical values of those scores don't really mean a whole lot.
Yeah.
But if
The rank
know,
matters.
the rank matters.
And the trend is uniformly across all these learning methods. The income comes up. At the
income
10.
is just never all that important.
Okay.
It's middle at best. There's a couple of questions that ask them, ask individuals, what would you do in a market downturn? You know, if you could take a little bit more risk and it would give you a higher return, would you do that? Like those are the questions that consistently are at the top of the list.
Okay.
Yeah. Whether they're twice as important or what, I can't really speak to, but yeah. Good questions. Thank you. Okay, so I am going to try and get through in about 5 to 10 minutes. The last project, talking about savings and investment. I'm going to go through this relatively quickly. Here's the basic problem. Slightly different set of data than we had on the previous slide. The RPQ data and the position data didn't necessarily communicate as well as we wanted. So we have nearly 7,000 market value trajectories, or we have a market value, the trajectory for the market value of an account, of all the assets in an account, for nearly 7,000 RSP accounts over this time period right here. And it includes COVID. For each account, we have details on every single transaction on every single day. And what we want to do here is identify the underlying characteristics of good outcomes, good trajectories, bad outcomes, bad trajectories. We want to be able to explain good outcomes and bad outcomes. And so we suspect we know what leads to good outcomes and bad outcomes, but we want the data to speak as loudly as possible. And so we're going to use unsupervised learning to sort of categorize these wealth trajectories into groups, and then have a look and see if we can identify, yeah, this group clearly is the best and this group clearly is the worst. And so what we've done here, here's a sample trajectory. We've normalized it so that everybody begins at $1. And so what you see here is this was clearly the downturn around COVID, March 2020. This was clearly a very large contribution. These trajectories are really, really complicated. The changes are driven by market factors, how you're investing. They're also driven by the contributions that you make, how you're saving. And so it's not entirely clear. This looks like a pretty good outcome, right? This individual, for every dollar that they started with, had about $1.60, $1.70 at the end of the period. That seems like a good outcome. What was it that caused this outcome to be good? Was it the way the individual was saving and contributing to the account, or was it the way that they were investing? It's a really tricky, the data is really complicated, and it's a tricky problem Okay, so what we use is dynamic time warping, which is essentially Euclidean distance, but allows for sort of, different frequencies and things like, I don't want to get too much into the details, but it is essentially Euclidean distance souped up a little bit. And then we compute for every pair of trajectories, we compute the distance between them using dynamic time warping, essentially Euclidean distance. And then we cluster on the resulting distances. So those distances are the matrix that feed into the clustering algorithm. The normalization that we're using here. So if that's the value of my count at time t, I'm subtracting off the minimum value. This is the way we're normalizing. I remove the low water mark, and then I divide by the difference between the high water mark and the low water mark. And so when this is close to 0, that's when I'm close to my minimum accounts balance over the entire period. When this is close to 1, that's when I'm close to my maximum account balance over the period. So a good outcome would probably start at 0 and get close to 1, right? And so we end up with 3 groups. One group clearly had bad outcomes. Thankfully, they were a very small group. And then we've got 2 much larger groups. This group tended to start near its low water mark and tended to finish near the high water mark. Everybody suffered during COVID, but this group had rebounded very, very well. So in my mind, the gold group is where I want to be. The blue group did okay, but they tended to start kind of halfway between their low and high water marks, suffered, and then maybe didn't recover quite as well. Okay, and so the way we've normalized, and I wasn't convinced that this was a good way to do the normalization at first, had to be convinced of it, am convinced now that it is a neat way of looking at things. So we have clearly a bad group, clearly a good group, and then sort of a mediocre group. All right. And so what is it that distinguishes these groups? In order to disentangle the savings behavior from the investment performance, we calculated the internal rate of return realized over the entire period. In principle, fairly straightforward, but actually going into the data and saying, yes, this was like a conscious decision on the investor to put money into the account. It should go in, and separating that from sort of dividends and other cash flows like that was like a really, really challenging problem. So we compute the internal rate of return. We also compute what we call the savings rate, maybe more appropriately called the contribution rate. And essentially that's just, okay, what percentage of your final value can be attributed to the contributions you made over our time window? And so this is how we're trying to separate out the investment performance. Remember, we said we wanted to say, are good outcomes determined by how you invest or how you contribute and how you save? This is going to tell us the investment performance, and this is going to tell us whether you were a good contributor or a bad contributor.
May I ask?
And so what we do actually,
I was wondering if I can ask a question now.
sure.
Sure,
I
go ahead.
actually-
I should apologize to people who are trying to get our attention in the chat. We've lost our TV reception here. So, but please go ahead with your question.
Okay, I noticed at the very beginning that you had roughly 300 advisors and 30,000 customers, which is kind of 100 per advisor. And
Mhm.
my wonder is, first of all, how can they handle it? But that's another question. The real question that I have, can you get the distribution or all the features of individuals without their names, of course, privacy, but those sub-distributions can teach you a lot, or am I wrong?
So, really good question. On the first point, if you look at the number of clients per advisor, there's almost a power law. There are a very small number of advisors that work with a shockingly large number of clients, and that explains the big average. The median number of clients per advisor is much smaller than what it looked like on slide 3 or whatever it was. And then the sub distributions, yeah, that's a really good question. What advisors are paying attention to? It's not, at least initially, it wasn't exactly clear. So we couldn't just say, okay, we're going to look at the old people here, the young people here, the wealthy people here, the not wealthy people here, because advisors clearly weren't paying attention to those obvious demographic characteristics when they were sort of making their recommendation. And when we look at how people actually invest, there's a big difference across account types. So RSPs invest differently than RIFs, invest differently than non-registered accounts. But the obvious sort of demographic features don't necessarily explain differences in the way people behave, in the amount of risk they take, in the number of transactions they make, and how active they are. Does that somewhat answer your question?
Well, I just want to add that the socioeconomic profile can be found from the location of the advisor.
Right.
People tend to get advisor near where they live.
Yeah.
Usually, unless it's a very specialist doctor that can do miracles.
Yeah.
Okay.
Yeah.
So
Yeah, that's a really
this
interesting
could help
thought.
too.
Yeah. That's a really interesting thought. Thank you for that.
Thank you.
Okay. Okay, so long story short, I'm going to wrap it up. We've got our good group, our mediocre group, and our weak group. And very clearly, the group at the top, the group that had the best outcomes, that was being driven by the contribution rate. There's a bit of a relationship between contribution rate and investment rate or investment performance. Our overwhelming conclusion here is that if you had to pick one, is it how you save or is it how you invest? The overwhelming conclusion we've come to is that it's how you invest. It's how you save, right? I don't care what you're doing in the market. If you're not contributing enough to that account, you're not going to get where you say you want to go in retirement. This is not necessarily surprising to the people in this room that kind of understand how, you can build really simple ODE models of an account balance with a rate of return and a contribution rate. And we all probably kind of understand intuitively that it really is the contribution rate and how you're saving that's going to determine that's going to have a larger influence on your performance. Like, what's really powerful about what we're doing here is that it's not just me, an academic up here writing down models, making up numbers, running simulations. These are actual experiences of actual Canadians. And because it's not just me up here at a board creating sort of a toy model, the hope is that this resonates much more with kind of the average Canadian, right? It's one thing for me to stand up here and explain something to a group. And if we've all been teaching, we kind of know how well that can go sometimes, right? This is actual experiences of actual Canadians. And the conclusions that we're coming to here are really consistent with sort of the, what you might do in a classroom. And so we hope the fact that it's data driven is going to resonate with the intended audience. So that's all I have to say for now. Thank you for your attention. And I'm happy to answer questions over the coffee break if I'm out of time.